Welcome to our chemistry lab. First, I will be talking about organic compounds. Compounds are only organic when they contain carbon and hydrogen, with a few exceptions, including carbonates and oxides. Here are the first 10 organic compounds: methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane. Name the compounds with their prefixes. The first four are irregular.
Look at this and think that, oh, it just has to,
One
doesn't have to have
is methane with one carbon. 2 is ethane with 2 carbons. 3 is propane with 3 carbons. And 4 is butane with 4 carbons. And the ones after are regular prefixes. We put these elements on a different shelf because they cannot be mixed with inorganic compounds.
To start off classifying our inorganic compounds, we started off with binary ionic compounds. As you can see over here, we separated the binary ionic compounds with transition metal and the binary ionic compounds with the exceptions. There are a few exceptions to naming binary ionic compounds. The few exceptions are the elements in group 1, elements in group 2, element aluminum, zinc, cadmium, and gold, silver. Those elements only have one specific charge, so there is no need for a Roman numeral to be placed after the first element. In order to name a binary ionic compound, all you have to do is just name the first element followed by the second element, which should end with "ide." As you can see over here, starting off with potassium chloride, the second one being zinc fluoride, the third one being calcium bromide, and the fourth one being barium arsenide. As you can notice, these elements don't have any Roman numeral in the names. Then moving on to this side, we have lead 2 telluride, which lead has 2 possible charges, which is 2 and 4. So it must be specified by the Roman numeral, which is lead 2. Then followed by mercury 2 oxide, then iron 3 chloride, and chromium disulfide, or chromium 2 sulfide.
Next in our inorganic classifications, we have acids and bases. Bases are easily identified because they have hydroxide by their first element. Acids are often combined with hydrogen. The bases that we have are ammonium hydroxide, aluminum hydroxide, barium hydroxide, potassium hydroxide, zinc hydroxide, and copper hydroxide. The acids that we have are nitric acid, hydroiodic acid, chloric acid, phosphoric acid, and hydrofluoric acid. Okay, we're going to start by naming bases. Bases have hydroxide, which we already know, and so the metal that it is bonded to is going to go first, and then you're going to have hydroxide at the end. For acids, there are 2 types. There are ones with 2 elements and one with 3. When you have elements like ClO3, you're going to call it chloric acid because the ion is chlorate. And so when it ends in ATE, it's going to end in IC when it's an acid, and if it ends in IT, it's going to end in OUX. Also, when there are only 2, for example, hydroiodic acid, you're going to put hydro at the beginning and then ic at the end. And acid to...
Alright, so next we'll be naming polyatomic ions. And polyatomic ions are compounds that have 2 or more elements in their name. So in this case, to start, you would name the cation, which in this case is copper. Most of the time it will be a metal, but sometimes there are a couple exceptions. Following the cation, you would name the Roman numeral, and you would do this to indicate which charge the cation has if there's more than one. After the Roman numeral, if there is any, you would then name the ion, which is determined by the number of oxygen atoms in the compound for the ion. In this case it is sulfite because it has 3 oxygen atoms, and the normal state has 4 oxygen atoms, which would be sulfate. So this would be copper 2 sulfite, this would be zinc nitrite, This is beryllium nitrate. This is sodium bicarbonate. This is potassium perchlorate. This is sodium sulfite. And this is the exception, ammonium iodate. This doesn't have any cation, but it does have NH4, which is considered a cation in this case. So we would categorize it as a polyatomic ion. We put the polyatomic ions on a separate shelf because they cannot be on the same shelf as these organic ions, the same as these and the rest are these inorganic ions. So they just have to be separated.